So Boolean algebra is nothing but there are some theorems and also some fundamentals of gates. So how to convert that gate. So these are all come under the Boolean algebra. In the fundamentals of computers, you can see computers, input output organization, input output devices. So under the flip flops, you can see SR, JK, master slave, T flip flops and decoders up to 3 to 8 lines, and also encoders octal to binary. Hello everyone, this is Asha, Faculty of Computer Science in Vidyashram First Grade College, the Temple of Excellence, Mysuru. So let's discuss the first sem syllabus BCA according to the University of Mysore. So the first is Digital Computer Organization. This is the new syllabus introduced by the University of Mysore, that is SAP syllabus for the first year BCA. Let's see what are all the contents you have in the syllabus or the introduction. So the agenda of this class is learning outcome. So learning outcome is nothing but after you will learn the digital computer organization, you will get to know what exactly the digital computer organization, what are all the uses. So and the units. So what are all the units and contents introduced by the University of Mysore. And next, internal pattern. So what will be the internal pattern marks, and also for textbook references you have textbook name. So next, learning outcome. So learning outcome is nothing but when you complete this course, you will get to know what exactly this course done. So the first point is understand the digital computer organization system, including classification of computers and also autonomy of computer, input output as usual. Basics of computers is nothing but the input devices and output devices, what are all the features and history of computers, evolution of computers. These are all included in the first point. And the second point is illustrate the types of software, computer languages and translate programs. So in previous days, in previous history of computer, there are some several languages, because as a human being we can't understand the computer language, because computer language is completely in binary digit, that is zeros and ones. So for that, using a translator we can get to know what exactly the computer language. And design and analyze combinational and sequential logical circuits like AND, OR, NOT. These are all some basic gates, fundamental gates we also call, and adder, flip flops, encoders, decoders, multiplexers and counters. These are all come under the design and analyze of combination and sequential logic circuits. And perform conversions between decimal, binary, octal, hexadecimal. So these are all come under the number system. There are two types of number system, positional and non-positional. So in the positional you will get a conversion like binary, octal, hexadecimal. So these are all the number system, and also carry out arithmetic operations in the binary format. So let's see the what are all the unit wise contents. So in the first unit there are 4 units. As per the new syllabus there are only 4 units. The first unit is the fundamentals of computers. As I told previous slide, there is computers, basic features or history of computers, and also input output device. These are all come under in the fundamentals of computer, that is completely basics. And come to number system, as I told in previous slide, it's all completely number system, that is octal, binary, hexadecimal. These are all come under the number system. And Boolean algebra. So Boolean algebra is nothing but there are some theorems and also some fundamentals of gates. So how to convert that gate. So these are all come under the Boolean algebra. So in unit 4, combinational and sequence logic circuits. So these are all come under the like flip flops, multiplexers. These are all come under in the unit 4 section. So see what are all the in the next slides we can see what are all the inside the contents chapter wise. So let's see. So unit 1. So you can see now. So fundamentals of computers. So in the fundamentals of computers you can see computers, input output organization, input output devices, and memory organization. Without memory the computer will be waste, right? So as a phone we want a memory, so mainly for memory purpose. And also computer languages, so like machine level language, high level language, and also low level language. So translator are nothing but it will translate low level language to high level language, so that is machine level language to human readable formats. So In the unit 2, you can see number system and what exactly the number system means, and decimal, binary, octal, hexadecimal. So we want to get to know what exactly this one. And also interconversion means we convert one number system into another number system, that is binary to hexadecimal or binary to octal or binary to decimal. And also same from the decimal to binary, decimal to octal, decimal to hexadecimal, like this interconversion. And addition, subtraction, multiplication and division in binary number system. So binary is nothing but only it contains two digits, that is zeros and ones. So binary is nothing but the only zeros and ones. So we can say only 2 bits it uses. So for that, addition. So addition is nothing but when contains 0 1 1 and also 1 0 0, we want to addition. For this addition we have some set of rules, we have to follow that rules, then only we got a correct answer. So the next ones and twos complement. So ones and twos complement is also come under the unit 2. So this is nothing but ones complement means all zeros converted into ones, all ones converted into zeros. So when I add 1, this is called 2's complement. So 1's complement is nothing but when I convert this one 1's complement, this is 1 0 0, this is 0 1 1. This is nothing but 1's complement, and also 2's complement is nothing but when I add 1 this, it will 2's complement. So that's it. And also some methods in binary number system, and also subtraction using ones and twos complement. So in next, addition of BCD numbers and non-weighted numbers, and application, excess gray code conversion, and also binary codes. So these are all the conversions after the ones and twos complement. So BCD is nothing but binary coded decimal. So these are all the contents we see. Next unit is the third unit, completely it's Boolean algebra. So we see some theorems like basic law, like De Morgan's law, commutative law, so associative law. These are all come under in the theorem, and also duality of theorem, and also sum of product method and product of sum method, Karnaugh map up to 4 variables, don't care condition, and some basic gates like and, or, not, and, or, not. These are all some basic gates. So they mention only design, we have to concentrate on the design, the structural design. So let's see in unit 4 contents. So these are all the unit 4 contents, combinational and sequence logic circuits. So in that you can see half adder, full adder, half subtractor and full subtractor, and flip flops. So under the flip flops you can see SR, JK, master slave, T flip flops, and decoders up to 3 to 8 lines, and also encoders octal to binary. So in the multiplexer, this is come under the unit 4. So 4 to 1 line, counter 3 bits binary, ripple counter, 3 shift registers, and also serial in, parallel out, and also parallel in, serial out. So these are all contents come under the unit 4. So let's see what are all the internal, how the internal marks will be added. So this is internal. So your paper should be 80 marks. This is theory. Theory paper will be for 80 marks, and remaining 20 marks, that is your internal. So that is your internal one. So internal 20 marks and also 80 marks should be main paper as per the university syllabus. So total 100. So in 100 for 20 marks, unit 1 and unit 2, internals 1, that is for 30 marks, and also unit 3 and unit 4, that is also 30 marks. So we can reduce that 30 marks to 5 or 10. So remaining 10 should be assignment or else viva. Assignment or viva. So in the 20 marks, so in unit 1 and unit 2, these are the portions for internal 1, and unit 3, 4, so internals 2. So internal marks should be 30 marks. 30 marks. So in the 30 marks, and again this is also for 30 marks. How it could be a 20 marks? For example, 30 marks, again we converted into either 5 marks or reduced to 10 marks or 5 marks, both. So then Remaining 10 marks will be for assignment or else the viva. So total 20 marks you got in the internal, and remaining 80 marks should be your main paper, exam paper. So totally 100 marks. And also there is no lab for this, there is no practical lab. So the question paper will be, as I in previous told, should be 80 marks. So for the book references, you can see the textbook. So you can see here Computer Fundamentals V. Rajaraman and Computer System Architecture 3rd edition Maurice Mene, and also Computer Organization by V. Carl Hamacher. So you can refer these textbooks for the extra contents to get a good marks or to get a higher marks. So these are all the textbook references. Thank you.